Great. Okay, my name is Toby Klima. I'm a PM on the Exchange storage team. I'm the current PM for the Jet database team. And we have Damon here, and the two of us will be talking to you today about all things storage. So our talk up until yesterday was actually dubbed Damon and Toby's Awesome Talk. Apparently that was not okay as the main title. So instead we'll be talking about email search and SSDs. Before we get into that, very important, we have a birthday today. So happy birthday, Squeaky Lobster. This is a very, very special check-in that happened almost exactly 21 years ago. No, not almost, 21 years ago. The birthday was today. We had a little party. We actually have him here in case people want to come by later. We made sure we brought him from Redmond. This is a photo of him on my desk, actually, and I have the privilege of working with the people that made this check-in 21 years ago. For those of you that are wondering, why the heck is there a rubber lobster on the slides and on the screen, or those that are watching online, go read that blog post. It's a great story. It also shows that the people that work on these technologies are really just that. They're just really nice people. From there, before we dive in, a couple things about what the current scale of Exchange Online is. So we just took this slide from last year and updated a bunch of numbers. We now run on more than 175,000 servers. This is front end and back end. We're in 47 data centers, so we continue to grow. In terms of storage, super exciting for us. We recently, a couple of weeks ago, only crossed the 1 exabyte mark. That was pretty cool. And some people said, it's just a number. By the way, I was one of those people. But it's still exciting when you grow by that much. Next, what we do every day. The numbers are just super cool. We route close to 500 billion requests every day. There are a few other things that get measured in trillions, but we're getting there. 1.5 trillion item reads or opens every day, and something like close to 10 petabytes of jet logs that we process. So this is where we are right now. We're still growing. It's still all working. And from there, I think we should start diving into the actual content. So off to Damon.
Okay. Hi, guys. My name is Damon Gilkerson. I'm the engineering manager for the Exchange Store team. I'm here today to talk to you a bit about BigFunnel, which, as you heard from the E19 launch talk at the beginning, is the new search index storage technology that we're rolled almost completely out to Exchange Online and are bringing on-prem with Exchange 2019. So the first thing I want to talk about is what motivated us to start thinking about building this new stack. The first thing there is overall simplifying the system. The previous search system, we had 2 parallel storage and HA stacks. That meant a lot of code that was doing essentially the same thing. Greater operational costs, higher alert volumes. So that was one of the things we wanted to go after. Next, as you'll hear more about in the second half of the talk, as we've gotten to a point where with larger and larger disks, we needed to start integrating SSDs into the system to be able to take advantage of those larger disks. And when we looked at it with in the search stack, we found that that was something that was going to be quite difficult to do. So we needed to take a different approach to be able to make use of SSDs in a cost-effective way. The next thing, as you've probably heard from our talks in over the years many times, we were very conscious of the cost of running Exchange, and especially the services, 170,000 servers. So there are a couple of areas of inefficiency that we wanted to go after in the search stack. One, just the memory costs related to having a single index for the entire database, as well as the fact that we were indexing messages multiple times on the active copy and on the passive copy. And finally, as we were looking at bringing some cool new features, we were finding that there were a set of features that we wanted to build that required access to both the core mail content and data that was in the search index. And in the previous stack, those would have been quite difficult for us to build. So those were the set of things that got us really starting to think about building this new search stack. So what benefits did we, as we built it, what are the benefits we're actually seeing? We've got one storage and HA stack for both the core content and the index. This means that the features that we've talked to you about in storage in past talks, things like single page patching, checksumming and repair of single page errors, all of those great HA features we've talked about you get now for both the core content and the search index. And again, as you'll hear more about in the second half of the talk, we've made use of SSDs to reduce search latencies by about 50%. Costs, again, like I said, big area of consciousness for us. The first thing there is CPU cost. With BigFunnel, when messages arrive in the system, and I'll go into this in a bit more in an overview of the system, but messages come in, land on the active copy, and are replicated via HA to passive copies. So it means we index the item only once, not 3 or 4 times. So that ends up having a pretty material CPU savings. Second, in the service, we see mailboxes with a large range of activity levels. Some mailboxes that do almost no queries, some that do a couple queries a day, some that are very, very, very active. Since BigFunnel moves us to a per mailbox index, we are able to unload the portions of the index that we aren't using from memory. Overall saving memory, which we've put to use in other places in the system to help us reduce latencies overall. And finally, since I've been talking about the index content replicating from active to passives, you may be wondering about what does that do to the network bandwidth needed for replication. And we've made some improvements in other areas, particularly around how we handle updates for small properties that got us some network savings. The net effect of the slight increase in log generation from BigFunnel and the decreases from those other features net out to roughly the same network bandwidth for replication. The last set of benefits I want to talk about are a set of innovations that we brought into the system. One that's really admin facing. This is, you may have heard about the service encryption with customer key feature. With the previous indexing system, it would have been very hard to apply that customer key to individual mailboxes. With BigFunnel, that just came very naturally. There's a reference to a couple of other talks on that topic if you're interested in learning more about the customer key encryption. And then the next 2 features are more end-user facing, which I'll go into briefly on the next 2 slides. So the first of those is a feature we call Smart Captions. This is rolled out to most of Exchange Online at this point and is coming on-prem in Exchange 2019. So the idea here, a coworker of mine, Preeti, is part of a photography group, and she remembers that there was an email about shooting from a different angle. So she searches for that. On the left, you see what the old experience would be, where the preview is the first few words of the mail, which may not be the most useful thing to find what you're looking for. On the right, we've highlighted one of the hits of those search terms in the message body, which helps her get to the result that she's looking for faster. The second end-user facing feature powered by BigFunnel that I want to talk about is a feature we call top results. And there's more on this one in an Outlook, what's coming to Outlook session, again, referenced at the end of the deck. But the scenario here, another coworker of mine, Jason, sends out a weekly status report mail, and he uses the mail that he sent the previous week to generate that. So he goes and searches for his status mail. On the left, he doesn't actually see the mail that he's looking for at all. On the right, we've gone and done some ranking under the covers, powered by changes we made with BigFunnel and technologies we brought in from Bing. And the mail that he's looking for ends up bubbling to the top in this top results section. From here, I'm going to jump into a bit of how the BigFunnel system works overall. Before I go too much through this slide, I want to call out one thing that you may notice when you see BigFunnel running on an Exchange 2019 system. If you're familiar with 2013 or 2016, you may be familiar with the node runner processes. And if you look at a 2019 server, you will see that they are still there. Wonder, well, if you've rewritten the search index, why are these processes still there? That's because BigFunnel is really about the index storage itself, not the other pieces. There's a lot more to the full search experience than just index storage. And a big piece of that is content processing, which includes language detection, filtering, word breaking. And those pieces are still running in the same content engine that was there in the previous releases of Exchange. You will see that the index node, while still there, is doing basically nothing. This is because as we roll things out in the service before they come on-prem, and we haven't gotten quite to the point in the service where we've been able to remove it 100%. But it's not in 2019, you will see it there not doing anything. I want to go with that out of the way, I want to go walk through what the ingestion flow looks like. Message comes in, whether that be through transport, SMTP, REST, any client endpoint. While the message is coming through that protocol endpoint, we'll send it off to the content engine to do that language detection, filtering, and word breaking. And then we'll generate a data structure we call the per object index that gets added to the message as it's saved into store. And store does some transformations on this to create a few internal data structures that are used to make sure that we're doing things in a way that minimizes the amount of I/O we do, while at the same time making sure that queries are fast. And then, as mentioned a couple times already, those changes, since they're part of the mailbox, part of the database, get replicated to the passive copies. But there may be, though we do very well at getting most stuff indexed in that on-save path, there are items that may miss that path because they're too large. That content engine processing takes a little bit too long. For those, we've got an event-based assistant that will respond usually within a couple of seconds to go read the message, send it through the content engine, update it back to store. And for the even smaller percentage of things that fail in that path, we've got a time-based assistant that goes periodically, reads message, sends it through the content engine, saves it back, saves the per object index back to the item. On the query side of things, this is the way oversimplified version of what this stack actually looks like, but the query comes into the protocol endpoint, transformed, do some transformations, it gets it into a form that store understands. Store does the internal processing of the query, does a first level of ranking on those results, sends the results back up to the protocol endpoint, which then may do another level of ranking before sending the results back to the client. Obviously, that is a very, very, very simplified view of what the query stack looks like. The next thing I wanted to talk about was what do you need to know as an administrator for dealing with BigFunnel. I actually considered just putting up the slide of what new commands you need to know for BigFunnel, and that's about it. We haven't introduced any new commands for BigFunnel, but there are still a few things that are useful to know. Again, since it's a per mailbox index, we've made some changes to get mailbox statistics that allow you to get a bunch of diagnostic information on the mailbox level. That includes number of items indexed, number of items partially indexed, number of items failed, as well as the sizes for those things and the sizes of the physical tables underneath. So that's the command to go get that. I mentioned the time-based assistant. Excuse me. I mentioned the time-based assistant that goes back and processes items that have been missed for one reason or another. You really shouldn't need to do this because it's running on its own, but if you have a reason to need to trigger that assistant, the start mailbox assistant commandlet will do that, providing the mailbox identity and the assistant name, which is on the slide. And then the last set of commandlets to talk about are are the commandlets that really actually have not changed very much. Test exchange search and get failed content index documents really have no changes. These will work exactly like they have in the past. A couple of HA commandlets have very, very minor changes for BigFunnel. In particular, get mailbox database copy status. You will still see the catalog status. That's to make sure that the commandlets still work with older versions of Exchange. For Exchange 2019, the catalog status will always say not applicable. That's fine. That's expected. And then update mailbox database copy. The reseed for the catalog only parameter on that commandlet. Again, it's still there to work with older versions of Exchange. But for 2019, it is a no-op. And then the last thing that I'm going to talk about is where are we now with BigFunnel? When I built this slide, we were 99% done with the rollout of BigFunnel to user mailboxes in the service. As of this morning, we were well above 99.9%. So very close in the service to getting all the way there. We have about that on-save path that I mentioned, about 95% of messages are indexed in that on-save path. And we get about 2% more for the event-based assistant path within a second. And then finally, we pay pretty close attention to P99 latencies in the service. And the current numbers that we see there for the store layer are about 600 milliseconds for Outlook.com and 800 milliseconds for Office 365 mailboxes. So that's what I've got for you today on BigFunnel. And with that, I'm going to turn it back to Toby to talk about MCDB.
Perfect. Thank you, Damon. Metacache database. When I heard that name for the very first time a year and a half ago when I joined this team, I thought, what the hell? What? Okay, that's a mouthful. What do you mean? I hope over the next 5 to 10 slides, it'll become clear of why we chose that name, because it actually makes sense when you understand a little bit more about what this thing does. Before jumping into anything technical, though, I kind of want to tell the story of why we did this. It's not like we sat around on a Thursday afternoon twiddling our thumbs or playing with the copious crustaceans we have in our team space that we decided we should build an SSD backend. No. This started when the decision was made to build BigFunnel, because we knew in order to get decent search latencies and knowing that a decent amount of the time spent in search was actually retrieving data from the database, we'd want to host that data on SSDs. So at that point, we knew certain data sets need to be on SSD. What's the easiest thing to do? Well, the easiest thing to do is to just put everything on SSD. For a cloud service, that doesn't work very well, unless you have a completely unlimited budget. By the way, shout out to those people that host on all-flash arrays. I wish I was you. That's awesome. We can't do that. Just doing envelope math on the plane yesterday, I came to a number of what it would have cost us last year if we wanted to convert the entire service to SSD, and it probably would come out somewhere close to $1 billion. While that is cool at an engineering level, at the latest, that stops when you go talk to finance. So that was not an option. From there, we had to think about, okay, we still need SSD for some of this stuff. What do we do? We built a hybrid backend. We came up with a backend that allows us to use a fairly small amount of SSD capacity, and we use somewhere between 4 to 6%, depending on server SKU that we use, relative to hard drive capacity to get some really cool speed-ups in search latency and also in some other scenarios. That was actually the next point here. While we achieved the goal of speeding up search, we also built a platform that allows us to accelerate other scenarios in the system. Some of those you'll be getting with Exchange 19, and others we're still working on now and making better as we go along. So we had some really nice side effects, I guess. So what are those benefits that I keep talking about? These two numbers, if you were at Ignite last year and went to Kathleen and Lynn's talk, you're already familiar with. We achieved about a 50% latency reduction for BigFunnel search, and this is comparing BigFunnel on hard drive versus BigFunnel with SSD backends. And we also were able to increase the speed of mailbox logon operations by 50%. That number is actually conservative because that measures the time it takes for the logon ROP to be processed. What we saw in full scenarios when you did a logon, we sometimes even saw reductions in logon latency of up to 80%. So that was really cool. The two new numbers I have for you this year are these: 2 to 3x faster mail access and around 20% more user load that you can put on a server. That's really the value prop. For 5 to 6% SSD, you can push 20% more load, depending on your environment, maybe more. That is what made it palpable for us in the service to do this, because we could pay for the SSD capacity with the higher load we can run our servers at. What this also gets at is the fact that we're constantly in this struggle to use larger and larger and larger hard drives, even though the hard drives aren't really getting any faster. So we want to increase density without getting more IOPS out of the drives. As an example, right now we have a large fleet of 10 terabyte drives deployed in the service. We're about to begin deploying 12 terabyte drives. And on the horizon, it seems that by 2020, we might have 20 terabyte drives. And we need to find ways to actually utilize these. So where did these numbers come from? There was actually a fortuitous event in the service, and these numbers that I'll show you here come directly out of the service, out of our dog food ring, actually. We had to, a couple of weeks ago, disable MCDB in our dog food ring for 2 days. I'll let you guess what days those are in the graph. So this is a Monday to Friday period. Each bar is 1 day. And this one measures the hard drive I/O that we experienced in the dog food ring Monday, Tuesday, Wednesday, Thursday, and Friday. When we disabled MCDB, the hard drive I/O nearly doubled, which showed us that the savings we got were actually larger than we initially expected. And this is, again, going back to being able to use large hard drives and having high density on our servers. This is how we achieve it. And this is what you'll be getting with on-prem Exchange 19. This is the I/O view. Here's the latency view. This is where the 2 to 3x faster mail access comes from. By having hits on SSD, especially for small messages, we can very, very quickly retrieve the data out of the database and just hand it back to the caller. To be clear, the y-axis on the second graph is measured in milliseconds. So you may wonder, what the heck? How does this take 0.2 milliseconds? How can it be this fast? That's because this is measured at the store layer. So from store, you still go through the Jet database cache. So depending on how high our hit rates are, a good chunk of the pages may actually come straight out of the DRAM cache, which draw down the average. But you still see the significant impact that MCDB has on even that measure, even though we go through the database cache. So that is the value that this provides. I will have one slide on a bit of architectural overview, and then we'll go into operation of MCDB. So the main point here is, what do we actually put in flash? What do we put on the SSDs? Since we only have 5 or 6%, we can't just go and put the entire message table in. That'd be great. But the message table makes up the bulk of the data we have in the service, because that's where we store all the messages. By picking and choosing very carefully, we're able to speed up very latency-critical code paths, such as search, or, depending on the data sets we pick, we can also accelerate and offload from hard drive operations that happen very frequently. So in order to make search quick, what we did was we took a vertical slice of the message table. Again, this is oversimplified. There's more to it. But we essentially took a vertical slice of the message table that has the most important metadata, hence meta-cache database, that is used to service searches. So titles, headers, dates. We also put into SSD posting list data and object indices. And that allows us to get very good latencies. Turns out that for a lot of messages, especially if they don't have attachments or very large bodies, this is all you need as well, or almost everything you need to retrieve such a message. Hence, serving mail is now faster. In order to accelerate logon, which was the other scenario I mentioned, we actually it was actually quite a bit simpler. For logon, because the data structures we need for logon which is the name properties table and the mailbox table, they're so small that we could simply say, yep, check the box, replicate the entire thing to SSD. We didn't have to pick and choose. So in the service, where we have MCDB rolled out pretty widely, almost all the mailbox and name prop tables are just constantly replicated to SSD, and that's why we get very, very quick logons. The motivation actually wasn't to make logon quicker. The motivation was to save hard drive I/O, because we found by using a fraction of our SSD space, I think it's around 4%, so that's 4% of 5% of total capacity, we get almost a 10% I/O reduction on hard drives. That's how hot these tables are. And that seemed valuable. If you want to know more about the architecture of MCDB, how reads work, how writes work, how the replication works, I encourage you to look at last year's talk where Kathleen and Lynn went into detail on this. The main reason I don't cover it here is because I only have 19 minutes left. Otherwise, if you have questions, come find me after, or I'm told I have booth duty tomorrow morning at 8:30, so I'll be there as well. What I really want to get to is this set of slides, and this was motivated by MVP feedback as well, so thank you very much. A day in the life of a Metacache database. I'll walk you through setup, through monitoring it, and what happens in case of SSD failure, which was a topic that many people were interested in. First of all, prerequisites. MCDB is based on the preferred architecture. If you build something completely different, then I probably won't be able to answer your questions properly. This is how we run it in the service. So make sure that you use DAGs that are enabled for reseed, and I'll reiterate this a couple times, make sure that the servers are symmetric in terms of SSD size and counts. So same number on each server and same size on each server. So how do we actually set this thing up? The first thing you will do is let AD know that you want to use MCDB. We created a new PowerShell script that is all you need to completely set up MCDB. You will start with what we have right here, manage MCDB, where we modify just the parameter set, call it with server enable MCDB, and give it the server name. So you call this on every machine to basically tell it, yep, when I start standing up databases, I want to take advantage of MCDB. The next step is to let the DAG object in AD know, hey, for this DAG, make sure I can use MCDB. Oh, and by the way, I have this many SSDs of that size on each machine that you can use for this. Based on that, we can then decide, okay, how much of SSD space do I give to each database instance? And I'll walk you through what that calculation looks like. It's actually relatively simple. As soon as that has replicated through AD, you can then take the last step, the third one, or number 4 in this slide, of actually doing the physical provisioning. So this already assumes you have the DAG set up, and you, on each server, make a call to manage MCDB with the configure MCDB server switch, telling it the server name and the SSD size, and what this will do is actually set up the volume mount points. The idea here is that you shouldn't even format the SSDs. We will do that. Just when you put the SSDs in, put them in, make sure they're online. They should be raw. We don't want to go out and try to find the SSD that you intended for us to format and accidentally delete any data. Leave them raw so we know there's no data on them. This command will go out, format the SSDs, create the volume mount points, and at that point, the logic that already exists in the service for reseed will kick in, create the database mount points, and you're good to go. Through that process, you will see the health state of MCDB change. We will start with storage offline. Storage offline means there's something funky going on with the hardware, or at least hardware access. It might be your SSD has died. It might be we cannot find the path that you pointed us to, or the path is inaccessible. It might be the mount point is misconfigured and points us to somewhere else completely, or we can't resolve it. That's storage offline. The next one will be, and this will resolve once the mount points are properly created through the setup mount points commandlet. The next one is offline. Offline means I can access the storage that you want me to use, but I don't know where my database instances are. That's where disk reclaimer, the logic that runs for reseed, comes in and creates the database instances for MCDB, at which point you'll get past the offline state. Next, we have initializing. You may not even see initializing, because usually this is just a transitional state, which can also be very quick, which means, hey, we're not quite sure what's wrong, but we're figuring it out. And then the last one that you'll end up with is healthy. Guess what? You're good to go. Yeah, woohoo. Operation. First of all, a quick piece on layout here. A question that had come up a few times is, wait, so how many instances of MCDB do I have? It's a one-to-one mapping. One database hard drive instance to one SSD instance. And that is true for the whole server. So take this example that I constructed here. We have a machine that has 12 hard drives and 4 SSDs. If we have 4 database instances per hard drive, we have to have 12 database instances per SSD. And we end up with this layout where essentially one SSD contains the database or the MCDB instances for 3 hard drives. From that, you can see, okay, we need to find a way to size these properly. How do we do that? I'll get into that in a second, but before I talk about sizing, I want to give you an idea of how we replicate content. There are 2 ways that we can get content into the SSDs. The first one is what we call organic growth. The DAG is running, you have mailboxes on it, you send and receive messages, and as those messages make it to the mailbox, pieces of them, again, that vertical slice in the message table, is replicated into the SSDs. And I say replicated because the content is still present on the hard drives as well. The SSDs we use here are a cache, not a tier. We don't master data in them, which allows us to do resets and other things as well that will be important in a minute. There's a second way that we can populate the SSDs, and that is through we call it a background filler, a background task, that basically just walks through your EDBs and populates that vertical slice of the message table. The background filler is going to do exactly nothing when it's a completely fresh DAG that's empty. But when you need to reseed from an SSD failure, or you need to even start fresh, that's where it becomes very useful, where we have seen in the service that a server on which we have probably upwards of 15 terabytes of data can completely refill its SSDs in a day or 2 with that background task. So that is just in the box as well. Now in terms of quota, how do we figure out the quota for these things? It's actually fairly simple. We take the SSD size that, by the way, you indicated in the commandlet when you set it up, include a 5% buffer, so we take 95% of that, and then divide by the number of database MCDB instances we need to put on this drive. So specific example here, a 960 gigabyte drive, take 95% of that, divide by 12 database instances, and we will allow each individual MCDB instance to grow up to 76 gigabytes, no larger. This is important because we want to avoid the case where we might run the SSD out of capacity. Turns out that databases really don't like it when writes start failing because the file system says, I can't give you any more blocks, I'm out. Kind of the whole point of a database is to persist data. When we can't do that, it's not ideal. So we are very careful to make sure we don't breach those quotas that are created. What happens when we approach it is that we begin evicting data from the SSD. And we can do that because we know we still have a copy of it on the hard drive. The way we do that policy-wise is we start with the largest tables first. That will almost always be the message tables because they make up by far the bulk of the data in the SSDs. And we trim based on doc ID. That's a fancy way of saying we throw out the oldest stuff first, which means most of the time, unless you completely overrun your system, you may not even notice that trimming has happened because typically the older content is less often touched and used. And that allows us to completely avoid these problems of running out of bits on the SSDs and having to deal with write failures. If, for whatever reason, the trimming doesn't happen quickly enough, the eviction doesn't happen quickly enough. The last way out for us is what we call an MCDB reset. A reset means exactly what it says. Kill that MCDB instance and start fresh. We actually delete the EDB file on the SSD, recreate it, and then the backfiller that I talked about will go through and begin populating it again in the background. And that reset is triggered when we mount on a database copy that has an unhealthy MCDB. So this doesn't happen when an SSD fails because we will usually fail over first. This happens if for whatever reason we have to mount in a place where MCDB isn't healthy. So let's go to the fun case. You're chugging along, everything's great, you get acceleration, and oh no, an SSD fails. This is well executed in the service, by the way, because at our scale we have SSDs fail every day, probably by the dozens. The very first thing that will happen is we will try to fail over. That's the whole point of a DAG. If an SSD fails, we want to make sure you still get the acceleration, you still get access to all your data, you still can serve all your queries. We will try to fail over. If for whatever reason we cannot fail over, we will mount in place. We will simply mount without the SSD acceleration. Now, as I just said, that will cause a reset, but you will have a mounted database that will serve queries. The next thing that happens is that, again, tying back to the previous slide, your MCDB health state will change to storage offline, giving you an indication of, there's something wrong with the hardware if you look on the server or query for state. You will also get a non-urgent alert. So you can listen for that and that way find out, yes, on server XYZ, I had an SSD fail, I need to go in and replace it. Here's where the first admin action comes in. You need to actually go and replace the SSD. If you have hot plug SSDs in your systems, awesome. We don't. We actually put our servers in maintenance mode if something like this happens, power them down, crack them open, and replace the SSDs. The reason for that is that we use M.2 form factor SSDs. We don't actually use 2.5-inch drives. It gives us more, again, guess what? It gives us more density in our servers. We don't pay the slot tax that otherwise would be a problem, where if you look at a 2U box that has, say, 20 drives, sometimes if you want to put in SSDs, people say, but now I have to give up some of my hard drives to make room for this. Not if you use M.2 SSDs, because those are those gum stick-looking SSDs that sit either directly on the main board or on a PCI riser. So you have them in the machine, they're just not hot pluggable. After you've replaced the SSD, the only other thing you need to do is call this commandlet again, which you called in the first place to set up the mount points, to find the SSD, format it, create the volume mount points, and now you're off to the races with reseed. As long as it was just an SSD that failed and we failed over, we'll reseed it from one of the other copies you have, which usually takes 15, 20 minutes because they're so quick, and you're good to go. Otherwise, if a reseed happened, we will just start from scratch, and the backfiller will do its work. And you are in a happy place again. Okay, a slide on guidance. This is just general guidance for when you want to deploy MCDB. Again, designed for DAGs and based on the preferred architecture. Stick to that. The second piece is 5 to 6% of SSD capacity relative to HDD is, we believe, perfectly fine for on-prem. We are perfectly fine with it in the service right now. If you want to go to 10%, you can. If you go beyond that, I don't see a way how you get significantly more benefit out of it. To avoid the hard drive slot tax, consider M.2 SSDs if you're looking for a hardware refresh anyway. I know I've beaten this to death, but make sure that you have a symmetrical layout. Same number, same size of SSDs on each server. That's what all of this relies on. Target somewhere between a ratio of about 1 SSD to 3 hard drives. In theory, you could just put one really large SSD in the box, and I know you can buy 4 terabyte drives these days. What you want to control for here is failure domain. You don't want one SSD failure eliminating the acceleration for your entire box. That is the main reason of using multiple. And then the last point really is SSD endurance. That was a question that's come up a few times as well. Do I need to get a write-intensive drive? Can I get away with a read-intensive drive? We're using mixed-use drives. So we source drives that sustain about 1 drive write per day. What that really means is if you have a 1 terabyte drive, you can write 1 terabyte of data per day, and you'll be within the warranty envelope for that device. There's no reason, given the load that MCDB serves today, to go to write-intensive drives, which are fairly expensive as well, because they need to over-provision a lot. So there is one more slide I have, which I can do this in 4 minutes. Has nothing to do with MCDB, but we wanted to bring it to you guys anyway, because you're getting it in the Exchange 19 release. We made some changes to how the database cache works, the DRAM cache that a Jet database utilizes. Again, last year, Kathleen and Lynn already spoke about what we call DB cache priority, where we can say, hey, for a certain client that may have bad cache locality, only give it a really small amount of the database cache, because it'll basically just pollute it and never come back. Think of bulk inserts from a migration. There's no reason to spend a whole bunch of memory on it just to age it out over long periods of time. So again, it's in their talk. Go look up their talk. The one I want to talk about here is what we call dynamic DB cache. In the service, it actually gave us, depending on which server we ran it on, a 3 to 7% reduction in I/O by being able to use more memory without increasing the allocation Jet gets. How did we do that? The first thing is, or the basic thing is that in Exchange 16 and before, we would assign a fixed amount of memory to an active database versus a passive database. And regardless of how many actives or passives we had on the server, that number would stay the same. In Exchange 19, we scale that amount dynamically based on how many actives and passives we have. This is actually easier to understand based on an example. So let's start with the case you actually have to size for, and that is max actives. The most databases you will ever have active on a given server in the worst case. For this example, say I have a server with 32 databases, max actives is 20, in which case I'd have 436 megs per active database, and I can barely read this, 109 megabytes per database for the passives. What happens when we go to a balanced case under E16, those numbers stay the same. You still use 436 megs per active and 109 megabytes per passive, but because of that, we now waste 3.3 gigs of memory that we could be using to make Jet faster and get more database cache hits. That is exactly what we did. So if you, with E19, run in a balanced scenario, we use that memory up, we give more memory to the actives, more memory to the passives, you get higher cache hit rates, and thus fewer hits, or rather misses, that then go to either SSD or hard drive. The nice side effect of this is that you will, say you set Jet to 25% of system memory, it will always be at 25%. It's not going to fluctuate. The call out here is make sure you size for the active case. Don't size for the balanced case now, because it's faster than the max actives case. So this is just a nice I/O reduction and perf benefit you get in E19. That was my last slide. So takeaways. Really, with BigFunnel that you're getting on-prem, you get a simpler, faster search stack that also allows us a platform for future innovation to bring future features to the product. And with MCDB, which in turn enables BigFunnel's speed, we can get fast search, and you guys can get denser servers with up to 20% more user load. We referenced a couple other sessions here that may be interesting for you. And then the last slide, I guess, is please give us an evaluation. And with that, I have 55 seconds left. So I'm not sure we have time for questions now, but as I mentioned, I'll be at the booth tomorrow at 8:30. Damon's going to be there at, what, 10? Later than 8:30. So come find us there tomorrow morning, or I'm sure we can spend a little time just outside now as well. Thank you.